So you'll not be working with the instructors when you join the real client project. You're actually going to work with our consultants, data scientists, as well as the project manager, and you'll be working directly with real companies and real clients on these projects for 6 months. And then we have career workshops. So these are group workshops that you can join twice a month. So we invite guest speakers to introduce, job skills, and then you also enjoy 6 months of one-on-one career mentoring. So you'll be working with the mentor. Okay, so that's that's what the timeline look like. And for part-time, again, it's just a longer duration, but typically student will complete the boot camp and then decide if they would like to opt into the real client project. So that's optional. Okay, but the boot camp itself comes with the one-on-one career mentoring. We have really great outcome. So we are a registered private career college here, in Canada. We have boot camps running in the US, but mainly online right now. So the only real number that we can report is the number provided by the ministry, because they call all the graduates. So we have to provide all of the student information, and they will call the employers. They'll be calling the students, and they publish the number. So these are the real number, not the numbers reported by the boot camps. So most boot camps will say they have 95%. It's absolutely not true. So our number from the cohorts in 2021 is 90%, or like close to 91%. I think what we did really well is that it's not just the employment rate, because I think when the ministry called the students about, their employment, it could be like students going back to old job, so they're still employed, right? And that's why you see other boot camps, they have 84%, 71%, but it's the yellow column that's more meaningful, which is the employment in the data field. So that means, you finish the boot camp, did you get a data job, right? So with us, all the students get data jobs. But if you look at other boot camps, the number drops significantly. So that means going from, for example, the second on the list, 84% employed, dropped to 68 employed in data. That means, 16% of the people are not getting data jobs. But if you look at the third on the in this table, it drops to 42%. But again, this is the number from 2021. I think the 2022 number is going to be published very soon. There's usually like a 1 year, 1.5 year lag, because the government is usually pretty slow. Our number in 2022 and 2023 is quite a bit lower. The job market is really tough. I think everyone knows that. So right now, I think it's about 70 to 75%. And between different cohorts, it will vary. But it's not I don't think anyone can achieve 90% right now in the job market, but I think 70% is still a really great number. I heard some other boot camps are only like 20% or something like that. And the reason why we're able to maintain a really good employment rate is because we have the real client project. So if you look at the support cycle, most of the boot camp, when you graduate, they provide some sort of career support, but that's it. Everything you learn is just technical skills. I don't think it's meaningful for you to go back to the same career advisor to ask for advice over and over again, because they're not even data scientists. They won't be able to maybe having 2 meetings, 2 sessions, but the third session, things start to become repetitive. They're not adding value anymore. But with us, I think the students will continue to work on the real client project. So what about those students, like 30%, who haven't found a job within 6 months after graduation? With WeCloudData, we put the student on the project, so they continue to work on the project. So they're accumulating experience, and then eventually they will get a job. So I think we commit a lot of time and effort to support the students, and that makes us WeCloudData different. Okay. All right, and now let's talk about the curriculum. I'll start from data fundamentals. These are just a prerequisite. I think if you would like to work in data, whether it's BI, data analytics, data science, data engineering, you absolutely need to know some of these basics, right? Including SQL, Python programming, data visualization. It doesn't have to be Tableau. So we teach Tableau in the fundamental course, but we also have the recordings for, because previously we ran Power BI. So we have self-paced materials that student can go through if you're interested in Power BI. But data extraction, data manipulation, and data visualization, these are some of the fundamental skills you need to know. And that's what you're gonna learn in the first 2 to 3 weeks in the full-time boot camp. And after that, the students will be moving on to data science. So in the data science course, we start from data collection. So we teach students how to do web scraping and data collection using Python, different libraries such as Beautiful Soup, Scrappy, or Selenium. And the reason why we teach data scraping or data collection is because if you want to build end-to-end data science project and to impress the employer, it is very important to do data collection yourself. And a lot of companies are embarking on generative AI nowadays. And we all know that one of OpenAI's core advantages is actually they have really solid data. Without great data and very well prepared and cleaned data, it's garbage in and garbage out, right? And a lot of companies will have the need to, for example, to fine tune and customize their large language models. So you will need to collect data and also annotate the data. So web scraping is actually a very important skill set. It helps you at the beginning of your learning journey to improve your programming skills quickly as well. And you can build interesting projects because you're not going to be working with the same data sets other people work with or download from Kaggle or from some other websites. And then we teach students how to manipulate data using data frame and different libraries. Data munging is a very important skill set to have before you start to do data exploration and basic data analysis, right? So in exploratory data analysis, we teach students to analyze and visualize data. Some basic statistics will be covered just to be able to answer business questions, right? Not all business questions need to be answered using like machine learning and AI. A lot of times it's just basic statistical analysis. So that's what we cover after we teach, the basic data preparation and manipulation. And then we move on to statistical data analysis. So there will be like regression analysis, predictive analytics, but these are the basics before we move on to machine learning. So we also added like auto ML. Recently, we are launching a generative AI course. So the students I think in February and March cohort will get free access to generative AI course. In that course, we also cover auto ML. And auto ML is actually, not hard, but it's a good skill set to have because you don't always need to write code in order to build machine learning models. Okay. One of the I would say the highlights of the bootcamp is that we try to teach students using like real life data sets. We've worked on many like data science projects. Some of our clients agreed to sort of share some of the real life data sets for the students to practice. So we'll be working with like real business cases. We have a lot of case studies, and you'll be using real data set, a redacted data set to build your projects or to go through the learning process. For example, when we do data analytics and visualization, some students actually will be using real Google Analytics and Google Ads data to build dashboard to do data analysis. In the data science course, we cover some use cases such as product analytics and digital analytics. So I think the business context is very important. I think most of the online courses, they only cover you the technical skills, for example, how to use pandas, to manipulate data. But I think it will be great if the students can be taught in a way that they understand the business context first before they start to apply those techniques. Okay. So that's data science. And after data science, we introduce machine learning. Machine learning has a big weight in the curriculum. It's almost half of the boot camp. So we begin with a quick introduction to the overall machine learning concept and workflow. And of course, you need to learn some math before you can do machine learning. So there'll be, some linear algebra basics, calculus, and statistics. And then we introduce packages such as, NumPy and SciPy. And then to learn linear regression, neural networks later, you need to understand optimization as well. So some of these will be covered in the course. And then we start to introduce the basic machine learning algorithms, such as decision trees, k-nearest neighbors. So these are the classic basic classification algorithms. And the goal here is just to help students understand, the workflow, right? How to use simple algorithms to train a model, and then how do you evaluate the effectiveness of a model, and how to do validation. And then we introduce students to feature engineering and feature preparation. In practice, you'll be working with a lot of features. Most of the Kaggle data sets you work with, probably have like 20, 50 columns. But in practice, you might be dealing with data sets that has like 4,000 features. So how do you do feature selection? This is something that's not covered enough in a lot of online courses. So we'll try to teach this from a practical perspective. When you have thousands of features, how to do feature engineering and feature selection. The methods you use will be slightly different. And after that, we introduce advanced algorithms, such as boosting trees, random forests, and of course, hyperparameter tuning. Machine learning pipeline is important. So you need to modularize your code and learn how to train models and hopefully automate the model pipeline. That's very important because when you join a big company, you're not always going to build like new models. A lot of times you're actually just operating those models, right? So the models might actually be automated, and you're retraining these models on new data sets, right? And maybe you're doing some fine tunings. So understanding how machine learning pipelines work is very important. And it's also important to know how to modularize your code. And model interpretation and communications of your modeling output is very much the key to the success of any machine learning projects. So that's something we cover as well. And after that, we shift from like the supervised learning to unsupervised learning. This is where students get introduced to like clustering algorithms, dimension reduction, and then we'll mention like anomaly detection as well using unsupervised learning methods. And after that, students will get introduced to deep learning. So we'll introduce the neural networks basics. Students will learn how to use PyTorch to write their own neural networks, different APIs, and then we introduce the basics of computer vision with a focus on image classification. The data science bootcamp doesn't have enough time to turn you into like an AI expert. So the goal is still to learn enough machine learning so you can you can apply for data science jobs. We do have a machine learning and AI engineering course or bootcamp where you can actually get more specialized in computer vision or NLP, large language model. But what we cover here is image classification. So you'll still learn like CNN, convolution, or neural network, but we won't be covering every aspect of computer vision, such as instance segmentation, semantic segmentation, object detection, and things like that. Okay. In NLP is actually more useful for most of the data science use cases. So we'll cover the basic pre-processing, so like just how to process text data, topic modeling, embeddings, text classification. Large language models will be mentioned, and you will be learning how to work with existing models. There's some interesting packages packages out there, such as Scikit LLM. There will be Hugging Face. So and all the BERT models, you learn some of these use cases. Okay. And then again, as I mentioned, we have generative AI training course. So we'll introduce students to the basics of Gen AI, LLMs, as well as how to do prompt engineering. Okay, so that's what we cover in machine learning, and there are a lot of real life use cases and data sets we use for teaching, such as Google Analytics, Google Ads data. There will be some Web3 data, which is based on one of the projects we did with a client in the past. We have mixed panel data as well. So most of these data sets are real data sets data scientists will be dealing with when they join a company. And we also cover various use cases. Okay. All right. And then the last component in the bootcamp curriculum is big data. Big data is very important because I think most of the data science curriculum tend to focus on pandas. Pandas, which is a library for you to manipulate data and basically work with data frames. It's kind of similar to SQL. The syntax is very different, but the way it works, right, is similar to SQL. You can do data selection, filtering, you can do projection, you can use pandas to do pivot tables, you can use pandas to merge and join tables and do window functions and things like that. But one of the challenges with pandas is that it only work with data that can fit into memory, which means it's actually not useful for most of the real life use cases. If you work in a bank, in retail banking, you work in insurance companies, in telecom, these are the companies that collect, hundreds of gig, if not terabytes of data on a daily basis. So there's no way you can fit all of those data into a pandas data frame. So usually the data processing starts from SQL, running in a data warehouse, or using big data tools such as Apache Spark, right, running on Amazon Web Services. If you work in some other tech firms, such as companies that does like ad agencies, right, working on recommender systems or e-commerce companies, the data is going to be even bigger. So pandas is a language you're going to use to deal with data that has been sampled, right? So you can use that to do a lot of the experimentation. But in production, I think many companies are actually using big data tools to process the data. And eventually maybe you can still use pandas to build and train a model. But a big part of the data scientist's responsibility is actually to prepare the data. So for that, you have to use different tools, such as Apache Spark. So in the big data course, we cover the basics of distributed systems. So you understand how MapReduce work, and we also cover how to scale pandas. So there are different other libraries that allows you to run, they have very similar API to pandas, but they can run data processing in a distributed fashion. So we'll cover that. And then we introduce students to Amazon Web Services, cloud computing. So you'll learn how to spin up EC2 instances so that you can run your own project. For example, when you run web scraping, data visualization, and even setting up your own open source dashboarding tool. And you need to know how to work with S3 and EC2. So that's what we cover. And we'll introduce you to the basics of Amazon Web Services, but we'll also teach you how to work with machine learning tools in AWS ecosystem, such as SageMaker. But before that, we introduce Spark. Spark is very commonly used. So it's quite popular big data tool, pretty much like the standard. It used to be Hadoop, but now it's Apache Spark. It's been popular for many, many years. So it has a data frame API and SQL API as well. So it's not hard to learn Spark, but you need to understand how it works, the mechanics, and the use cases. So we'll teach basic Spark APIs, and then we'll teach students how to scale machine learning model training using Spark ML library. So you'll learn how to scale machine learning pipelines. And then in the end, we cover a little bit MLOps. Again, this is a data science program, so we don't emphasize that much on MLOps and ML engineering. That's a different course, but just for the students to have an end-to-end experience, we do cover MLOps basics and teach students how to scale ML using Amazon SageMaker and how to deploy models using SageMaker. So that's the big data course. And we also provide some real life data sets, such as the Medicare data. We have some digital advertisement data, which is pretty big, and some product analytics data. So the use cases will be quite different from the machine learning course. So we tend to use big data set. And the problems we're solving here are, fraud detection, CTR, click-through rate prediction, So the data set is usually pretty big in ad tech companies, recommended systems or building knowledge base and things like that. When students later on work on a real client project, right, they might come across projects like, building chatbot using large language models or using vector databases to build a knowledge base. You don't necessarily learn everything in the boot camp, but you're learning how to learn in a boot camp because you'll get exposed to a lot of new information. There are new topics, right? New knowledge you're gaining every day. You're doing a lot of problem solving. I think in 3 months you're going to improve your problem solving skills, your learning capability, so that when you get put on real client project, you will know how to solve those problems and learn something really fast, right? And you will be joining a project team and work with the project managers. You might be assigned tasks that are new, and you should have the confidence to learn something really quickly, apply that, because that's how it works in real life, right? So that's the curriculum. I think after you complete the boot camp, you will be able to add new, keywords or skill sets to the resume. So if you look at a typical resume, you need to have the key skill sets. So that's what you're able to add, right? You're going to have, coding skills, machine learning skills, data analytics, visualization, but you can add cloud, big data, Spark. So that will make your resume very relevant in the job market, right? But it doesn't help you get a job yet, because I think to be able to land a job, you need to be very competitive in the job market, and that's why you need a relevant experience. The bootcamp doesn't necessarily help you add experience. It helps you gain skill set, but to stand out, you need some sort of real experience. That's what the real client project can give you. So that's, I think, one of the benefits of doing a bootcamp with WeCloudData. That's it. That's my introduction to the curriculum. I can also talk about like the job skills and how we can help students with through career mentorship and real client projects. But before I move on to these topics, I just want to pause and see if you guys have any questions about the curriculum. Feel free to ask questions.
Hi, everyone.
Hello.
My question regarding the MLOps and AWS, more specifically, at SageMaker, do you think like learning SageMaker and the Vertex AI from Google would be like a great futuristic job? Like somebody who is more professional using the use of those platform will be something like a, let's say, SageMaker expert or Vertex AI expert. Thank you.
Yeah, that's actually a really good question. First of all, I think that you mentioned two tools, SageMaker and Google Vertex AI. For those of you who are not familiar with these, so they are like managed machine learning services. So it's kind of similar to scikit-learn, but scikit-learn, PyTorch, these are just Python libraries that allows you to sort of train and tune machine learning models on your computer on any server, right? You just need to have Python and these packages installed, and you can just you can just do machine learning. However, one of the biggest challenges of machine learning in production is actually the compute, right? So you need, first of all, you need data, and the data might be really big. As I said, the data doesn't fit onto your computer. So you're going to store the raw data either in a feature store, in a database somewhere, or in an object store, right? Like it's just in a big data storage system in the cloud. So it's either AWS or Google Cloud. And then you need compute. When the data is really, really big, you need more computing power. But when the data is tiny, you also don't want to waste computing resources. So that's why there are services like Amazon SageMaker or Google Vertex AI they allow you to scale the computation, right, down and up and down really, easily. So they're building like APIs on top of, right, the basic PyTorch and scikit-learn. You can still use these in these libraries in SageMaker and Google Vertex AI, but they sort of wraps, they wrap the compute resource, like resource management, right, all of these, and give you the capability to modularize your code, and also manage those cloud resources. It's pretty powerful. Now, back to the question, I think the fundamental skills or the core skill set you need to have is still your fundamental understanding of machine learning workflow. For example, how you extract data, how you prepare the data, how you do feature engineering. And these have nothing to do with, SageMaker or Vertex AI, because these are just tools, right? So I think knowing SageMaker and Vertex AI will definitely add, make your resume more like, it's more sellable, right? But I don't think that's the core skill set of a data scientist, because I've seen a ton of people who's very good with tools, but when you actually ask them to sit down and write a good model, they're not really good at it. But they learn a lot of different tools, and they went through a lot of tutorials, because you can find free SageMaker and Vertex AI tutorials out there, and you can go through these and add that to the portfolio. It doesn't make you a very good data scientist. I think a data scientist, the strength is really still in the data and how you process the data, how you engineer the feature, and if there's one important skill set you need to have, I would say it's actually how you scale the system and how you automate the entire pipeline, which means you need to be familiar with ML pipelines, modularizing your code, and you can scale them. That requires more engineering skills. But working with SageMaker, as long as you know how that works, it's really just a matter of like working with a different API. So that part, it's supposed to, like, SageMaker is supposed to make your life as a data scientist much easier. So it's actually not very hard to learn, right? So yeah, adding these tools definitely will give you some benefits, but I wouldn't say that's the core skill set. So I don't think the company is going to hire you because you know SageMaker really well. Because for a lot of the companies, SageMaker is quite expensive, right? If they want to hire someone who's more senior, it's definitely someone who can help them not only scale things, but also save cost. And from that perspective, Netflix is running everything, like they run Spark and Hadoop, but they never use like Databricks solution. They actually just use the open source, and they have the expertise to sort of operate their own big data cluster themselves, because they can save a lot more cost if they do it that way. So if you want to become like a more senior engineer, data scientist, MLE, SageMaker is just a tool in your toolbox. It's not going to like help you differentiate that much.
So if I want just sorry for jumping in, to emphasize or to say something regarding the data science part of it, I mean, you have to understand in the business first before you can really jump to the tools. It's like driving the car to nowhere if you don't know where you're going.
Yeah, I totally agree with you, Steve. So I think if I think there are two parts to this. So first of all, if you think about this from a job seeker's perspective, your goal is to land a job. And I think hard skills still very important, because it's chicken and egg. Before you become a data scientist, it's kind of hard to prove to people that you know a lot about like the business, context.
Exactly. Because how do you know if the data is really meaningful or present something before even you go to the gap inside the data?
Yeah,
You know what I
yeah,
mean?
yeah, I agree. And then when you actually start working as a data scientist, I think what differentiates someone who's more senior to someone who's relatively junior is actually the business knowledge and how you
Exactly.
communicate
Thank
with
you.
the. So for people
Thank you.
who can
Yeah.
actually, climb the ladder and do really well in data science, only having hard skill is not important. Is not enough. I think you absolutely need to have good people skill. You need to have good presentation skill as well. And of course,
Exactly. And understanding the business.
Yeah, and of course, business can be learned, right? If you only know the business, but you're not strong technically, most of the time, you'll be filtered out. So, because most of the time, employers, recruiters will be looking at your technical skill. So you absolutely have technical skill first, but as you work through those technical skills, you need to make sure that you gain enough business context, business knowledge,
But
to understand how these models are actually used in a specific industry. Right?
yeah, yes, but what I'm saying is for example, for myself, yeah,
Yep.
I have a very good say business skills in the healthcare, which has a lot of big data and very good technical skills in SQL Server and Transact SQL and all of this and how to, to extract data and how to build it. But meantime, if I start to pick up some knowledge, technical knowledge, it'll be easier for me because I can right away relate it to my business skill and my data skills.
Yeah, I agree with you. I think the business knowledge and skill is very important. Yeah. But there's, in the data field, there's also data analytics. So I think if you have very strong in data in business, and also you're good with SQL, right?
Yeah,
A lot of the data analytics, like jobs, it
yeah,
could be perfect fit, right?
yeah,
But comparing data analytics to BI to data science, data scientist, like data science jobs are still way more technical because
yeah,
just in the sense of like programming, but you need to know like more math, machine learning, right? More
exactly.
algorithm. So the technical skill set is still very important if you want to land a data science job.
I agree with you, but it's much, I would say, intuitive, and it's easy for you to learn the technical skills because you right away apply to your knowledge. Right away use your knowledge and try to apply it, which is easier.
Right on. Yeah, I agree. Thank you. Any other questions about the curriculum or the skill set you need to learn? Cool. Well, let's move on. So in the boot camp, I think, or any online courses you do, or college programs you graduate from, you're going to gain hard skills, right? But hard skills don't necessarily mean job skills, right? So you can gain skills from different sources, and you're going to add these keywords to the resume, right? Python, SQL, Spark, and you spent months of effort. But it turns out that having hard skill set alone is not enough. You need job skills, right? Communication, business knowledge is important, but there are also other aspects of the jobs you need to know. So, and hopefully you can gain these skill set and experience, in a program. So let's take a look at a typical data science or data science workflow, right? If you work on a new data science project, and the demand must come from the business team first. It could be sales team, product team, right? Marketing, risk team. They are the driver because they need to hit some sort of KPIs. It's driving some sort of data analytics and data science needs, right? And the data science team will be tasked, with the data analytics, modeling, and all of these, but typically it starts from scoping the project, right? Like, what are we trying to achieve, right? What's the metrics we're trying to optimize? How much budget do we have? And then you move on to data. Like, do we have the data to support our data science project, right? And the goal is to, let's say, to reduce customer churn, right? Or improve the revenue or something like that, right? So it starts from data. And then once you have the data, you're going to move on to the exciting part, right? That's the sexy part of data science, which is modeling, predictive modeling, and that drives insights, right? So for some of the projects, you just need to do data analysis and visualization, and that's business insights. But for some data science projects, if you work with a product team or software team, your data science models might need to be deployed in production, right? So it become part of an integral part of the product or the software, and then you have to do test and learn. You're collecting data again, so you go through this, different iterations, right? Now let's take a look at this, in more detail. So hopefully I can help you dissect this and understand it's not just Python and SQL, the hard skills, and you need some other skill set or some other experience that you can add to the resume. Okay. First of all, when you do project scoping, the data scientist, herself might not be the person who's doing everything, but when you work in a team, I think it could be your manager, or it could be the product manager who's collecting requirements, right, or the project manager. So requirement gathering, right, understanding what the business stakeholders want, and doing a lot of clarification, because a lot of times they don't even know the right question to ask. They thought they're asking the right question, but really they're not. So it's the data scientist's job sometimes just to tell them you're wrong, or you tell them that, well, clarify things. Like, is this really what you want, right? And then sometimes, your CEO, your director may want you to do something, but it turns out it may not be feasible, or the cost is too high. So you may want to do some like proof of concepts or just feasibility analysis. Maybe you're heading before you head down the wrong direction, right? And it also requires cross-team communication, because you might be collecting requirements from the operations team, from the marketing team. So you'll be in all kinds of meetings, and usually it's like the data science team manager or maybe the senior data scientist. It depends on the I guess the team dynamics, but sometimes even if you're junior, you can still join those meetings to learn, right? And you need to write technical proposals. If you work, for a consulting company, you need to be part of that like proposal writing. But if it's for like internal teams, it might not need to be that formal, but you still need to have some documentation, right? And you might need to become like a data science architect, because you need to know how to translate the business requirements into a data science pipeline or workflow, right? And then the first thing you need to do is, well, do we even have the data? And do we have the data infrastructure, right? Is the business requiring to run everything in the cloud? Then do we have that environment, right? Maybe a lot of companies, they have cloud infrastructure, but it's run by IT. Maybe it's not ready for data science, right? And maybe your company didn't even subscribe to some of the services.
Can you go back to the previous slide? What was the last part there? The last point? Yeah, this one. Yeah.
Oh yeah.
Relationship building. Oh,
Yes.
okay. Relationship building. Okay.
Yeah. Yeah. So, when you move on to the data part, right, before you start to do data science, I think there's quite a bit data engineering stuff going on. I think the data scientists will need to understand how that works, such as data infrastructure. Data scientists are not the team or person who's building the data infrastructure, but you're definitely involved in it, right? Data governance, for example, what type of data we can analyze, what type of data we cannot analyze, right? And then data modeling, for example, how you model the relational database, that sort of decides how you're going to write queries. So data science team are usually not the teams that are going to build the data models, but they can work with the data engineering and IT departments to work on the data models, because data models are ultimately created for the end users, which are usually BI teams or data science teams. So you'll be involved in this as well. Data collection. Data is usually ingested by IT or data engineering team, but the data science team will be creating like the requirements, right? What kind of data you want. And sometimes if the IT team is very busy, you might actually need to roll up your sleeves and just do some web scraping yourself, and to not only collect the data, but also label and annotate the data for machine learning, right? And when things are put in production, data pipelines need to be automated. So data scientists will be working with data engineers and tell them how the ML pipelines work. And it's definitely a teamwork, right? So understanding some of these will definitely be helpful. But all I'm saying here is that you don't work in silo. You need to work with different teams. So the more you understand about data infrastructure, data collection, data pipelines.
I have a question.
Yeah.
So can you elaborate more on the governance and the modeling aspect, please? Thank you.
And where the security is coming to play, it's in this stage or different stage?
Here in data governance and data modeling, what things you are encompassing here?
Yeah, okay, I can answer these questions. So for data governance, s- it's it's a very big topic. But data governance also, covers, data quality, right? So
Yeah.
it's not just the quality of the raw data, but data scientists often are involved in data quality because the data engineering might prepare the data in the correct way, but it may not be useful for data science. So data scientists will need to give feedback to the data engineering team sometimes. Or when you go through data analysis and do visualization, you realize that there's some data challenges or the data is not correct, right? So you can give the feedback back
So
to
you design also business rules to prevent from bad data to get entered?
No, I don't think it's the data science team that's designing these rules. But if you're involved in this, then you will need to give feedback to the data governance team or the data quality team, whoever who's preparing the
Yeah,
data.
that's what I meant. That's what I meant in the governance. So it's
Yeah,
a part of this is the business rules and also the security, right?
yeah. So, well, it depends on the type of security you're talking about. But here it's more.
Regular login security and where you can go and where you can, some area of the system you can go there and some area no, depend on the users.
Yeah, I don't think this is what data scientists usually care about. I think the governance side,
Yeah,
more about data privacy, right? So there's some data that you can analyze, some data that you cannot analyze. And sometimes, you need to understand the regulation. When you build credit risk modeling, some of the features you use, it may actually, you're basically it's like some industry, heavily regulated industry, may prevent you from using some of the features to train your machine learning models, even though that feature can maybe help you build better models, but it creates bias, right? Maybe you should not be using gender and age to build models in some industry. So you need to understand these, rules, which is, part of, data governance. But I think data governance overall is something that falls under IT and engineering team. But the data scientists will need to understand some of these rules and policies.
Okay.
Yeah, but that's not like your job responsibility as a data scientist. Okay. Um,
But I think that's when you coming to be a data scientist, there's no like clear borders cut, dry and cut. It's always some overlapping, depending on the organization.
Yeah, I agree. And also it depends on the seniority. I think
Yeah,
if you work as a junior data scientist, you probably don't need to worry about these because your job is probably more focused on, a very specific tasks. Like, okay, you need to do data preparation, feature engineering, or train and fine tune the models.
right.
As your responsibility increase, you become a data science team manager, senior data scientist, you start to deal with the people from different teams and deal with all kinds of requests and join different meetings, and you'll be in a governance meeting because people need your opinion and things like that.
Yeah.
Okay. All right. So once we figure out the data, right, where to get the data, and then the data scientists will need to move on to machine learning, predictive modeling. And I think this is what you learn in most of the curriculum,
I'm
right?
sorry. Can I stop you? So I have a quick question. If you
Yeah.
can go back to the data part.
Yeah.
You mentioned about the data modeling. Where does the data transformation and preparation is there? Like, for example, if we are bringing or if we are using different sources of data, like if it's a banking data, we are using the credit bureau information,
Yeah.
or the demographics information, the transactional data. So how does the data quality aspect, how much is it essential from the data science perspective?
Yeah, that's a good question. So when I say data modeling, it's not the data scientists that are going to create the data models, but they are the users of those data models, right? So when you work with data sets, or tables from, different departments, working with data marts, you might need to bring data from, let's say, 5 different tables, right, in order to create the modeling data set you need. So you need to understand the relationship of those tables. So data scientists
Exactly,
don't
but you
create those
also need
models.
to understand the business. Otherwise, you cannot understand the relationship.
Yeah, I agree. So you need to understand the data models, but that's, data models basically, encode the business rules, right? It tells you how the tables are related to each other, right?
Yeah.
So you need to at least understand the data models, ER diagram, and things like that, so that you can write efficient queries to get the data you need, so that you can move on to the modeling stage. So yeah, data scientists will at least need to know how to write queries and understand the data models, right? And so a lot of times, like you don't just read like a diagram and figure out the data model. A lot of times it's like just by experience, like you start to join tables and learn the rules. And over time you get familiar with these data and tables. Yeah, but that's just the basics of data modeling, right? And there was another question. Sorry, I got carried away. The question was, MRD, if you don't mind, can you just repeat your question again? I think you had a question about data
Sorry, I
modeling,
was on mute.
something.
Yes, sure. So my question was sure, it's more to do with the data quality aspect. So how essential and what is the role of a data scientist? Like how much involved is that? Like for
Okay.
example, you mentioned
Yep.
about we get familiar with the tables and the data sets which exist in the on-premise environment. But if there are issues with the data quality, what things we need to take care from the data quality
Yeah.
perspective if we
That's
identify
that's a good question. So first of all, data scientists usually don't do ETL and ELT, right? So in production, I think it's the data engineers who are going to build data pipelines and do all the transformations based on the business rules. However, um, you know, that achieves, let's say, maybe 95% of the data quality, but still, like you're always going to have bad data and things, that cannot be fixed by your data pipelines. So when data scientists start to work with those data, they will always find those issues, because when you do feature engineering, you're always going to do, before you do feature engineering, which is part of machine learning, always need to do exploratory data analysis. So that's when you're going to visualize the data. You're going to do like, describe the tables. And that's when data scientists will find a lot of problems with let's say the product code, and there are a lot of legacy problems, right? The company has gone through a couple of merge and acquisitions, and they bring different, IT systems from different child companies together. And so it's hard for the data engineers to sort of build pipelines and fix all the problems in the data. And when the data scientists build machine learning models, they do need to have high quality data. And that's why sometimes if there are quality issues in data, they will basically have to write their own pipeline. So part of the data science pipelines is actually data quality and fixing the bad data. They're going to use their data science skills to do that, right? So they need to give the feedback back to IT.
Sorry to jumping into fixing the data. It means that you do something. There has to be a rule into it, and some of the rules intuitively, even some rules you have to understand the business and ask the people, because you cannot make all the decision by yourself.
Yeah, I agree. Like data scientists always need to communicate with the team, right? So you don't just for example, like you maybe have a product code 999.
Yeah.
Does it make sense? Like or like you at least you need to understand, like, why is this happening, right? And there might be some, problem with the way data was collected in your software.
Yeah.
But I think over time you'll need to learn these rules.
For example, end time of a job cannot be before the start time,
Yeah, makes sense.
It makes sense. But meantime, you can have a lot of records coming in with this mistake, and
Yeah.
and what you do, how you fixing it.
Yeah,
How do you?
absolutely. That's part of that's part of the job, responsibility of a data scientist. I think um, even after data cleaning, and data transformation by the data engineering team, The data will still have a lot of quality issues, and sometimes it's just not worth it to fix these problems in the data engineering pipeline. And data scientists will just need to write function, like you need to do data transformation as well, and you need to take care of these problems in your code to make sure that the data is ready for is robust enough for you to train a machine learning model.
I think you should touch on a very sensitive and very important subject, is how you trust the data, because in organization people can tell you, oh, we don't trust this data, don't come to us, and apparently you can work so hard to fix the data and they still can tell you, oh, we don't trust the data. What you do, you develop a model, you go on and on and on, invest more time and more effort into it.
Yeah, thanks for your input, Steve. I think we spent too much time on this because we're just going through a data science bootcamp info session. For the technical part, we can discuss that later.
Okay.
Is that fine? Yeah, thanks.
Yeah.
Okay, so after we figure out the data, we're going to move on to the modeling part. So you need to do data set preparation, feature engineering. So you're going to do, like when you do data preparation, you're going to do some data cleaning as well. For example, there might be product code 999. From a data engineering perspective, that is the actual product code. Like there are some business rules. Whenever if you don't know what is the right product code or it's missing, maybe they just encode that as 999. So from their perspective, it's not wrong, but it's not useful for you to train a machine learning model. So in this case, the data scientist will actually need to know the right way to prepare the data for modeling, right? So that's data preparation. You need to do feature engineering, and then move on to predictive modeling and model like machine learning model training, right? And part of it is selecting the right or the best models and test it, validate it, and then you go through multiple iterations. And it depends on how fast you would like to move. And some for some businesses like retail, they may prefer to just iterate really fast on modeling, and you can retrain the model on a daily and even weekly, even daily basis, because even the product catalog, right, is seasonal. They're always changing the product catalog, and so you need to sort of constantly rebuild the model. But for some industries like the banks, they don't want to change the model very often. So it's going to have a lot of big impact on the business bottom line, and also they have to control the risks. So they spend longer time, testing and validating the model. And once the model is built, they want to use it for years, right? So, and in advertising business, sometimes you retrain the model on an hourly basis. So you're going to for sure go through a lot of iterations. In some companies,
can I add one point here?
Oh, absolutely. Please go ahead.
So just based on my experience with data science, I think the model data preparation is very essential. But before we actually start with the data preparation, what I've seen is essentially the business want you to know, like, if there are different segments, customer segments, based on the credit score, let's say high, medium, and low. They first decide that, okay, they want to build the models on a specific segment or what level of granularity they are looking at the data. For example, they want to predict the customer lifetime value, or they want to predict when is my consumer gonna buy my product in next 60 days or 90 days. So I think the business, the model requirements is also one of the other aspects before we start prepping up the data for model. Just wanted to add that. Thank you.
Yeah, that's a good point. That's part of data preparation. So like sampling, selecting the right segment. But you'll learn these when you start to learn data science. But that's a very good point. Thanks. So after the modeling, I think the model can be used for different purposes. And for a lot of businesses, sometimes building machine learning models, actually you use it to explain things, right? You want to build models to discover insight. So you need to focus on model interpretation, because the business will want to understand, if they understand the model is very accurate, it has been validated. But if you want to use it for some sort of prediction, and then the business is the team, they are the party that's going to actually take actions on these models. So they want to understand, why do you think someone is high risk? Because if they don't understand that, it's kind of hard for them to come up with like business strategies to deal with the customers, right? And if you have like customer who's unhappy, who's going to cancel the product, the business will also want to understand what are there any other reasons that could cause a customer to be unhappy and leave, and different customers will have different reasons, right? Driving them to churn or causing them to become high risk customers. So you not only train the models, you also need to do some post modeling data analysis. So data analysis visualization is also useful even after you have created the models, right? So that's the insights and analytics part. And then of course you need to communicate with the business and do some business presentations. And this is a step where you actually build trust, because if you can explain things really well, business will have the confidence to actually adopt the model you use. And it's very, if your model is very technical and you're just expecting the business to understand everything on their own, then sometimes you're damaging the trust there, because they are not trained data scientists, and they don't necessarily understand statistics and how machine learning works, right? They understand that you're creating a prediction or a score, but they really want to understand how that works. And sometimes like it's even hard for them to understand that your model, to trust that your model is that accurate before they start to work on it, because they are the cost center. They're going to spend money, right, and start to adopt a model, and they have a KPI. So you need to help them to sort of ingest some confidence into that process. And that's why you don't just provide the model to them and say, hey, take it, it's 90% accurate, right? You need to provide a lot of like small analysis and even build some small dashboard to help them understand the full picture. That's very important. Okay. And of course the goal is to help the business to have positive ROI, right?
I got a question to ask you here. In this case, this is where you do the distinguish between predictive analytics and prescriptive analytics in the model, or where?
It could be descriptive analysis. It could be predictive analysis. So in the sense of predictive analytics, let's say we're building a churn model predicting who's more likely to churn.
Yeah.
So you're actually building a predictive model, and that model will be used to predict, who's more likely to cancel the subscription in the next 3 months. So the business will contact these, communicate with these high-risk customers, and hopefully they can do the retention and prevent them from leaving, right? That's a predictive model.
Yeah.
But the business will want to understand. They always ask you, so can you tell me the top 5 reasons why someone is leaving, right? So they need to understand the why, so that they can come up with the business like communication strategies. And so the marketing team will probably want to do further like segmentation on modeling results, so that they can come up with different promotion plans, right? Because you don't just have like one.
So different promotion plan. For example, in this example, will be the prescriptive analytics, right?
Right. So you're building a predictive model, and then you're going to come up with the solution. So I guess that's prescriptive analysis. Yeah.
Okay.
Yeah. Okay.
So
Cool.
this is the step, right? This is the step. First predictive and then prescriptive, if you want to go further.
Yeah, so I know there's some like process people follow, like you do like a descriptive analysis first, and predictive and prescriptive. Yeah. Yeah, I've seen those, but like I think what you said makes sense. So when we build a predictive model, it's predictive, and then if you would like to apply that, right, and use that to generate like insight, and that's probably the prescriptive part. Yeah. And then all the data exploration stuff is probably just descriptive. That's what the data analysts do, or the first part of data machine learning, which is data exploration. Yeah.
Yeah. Okay.
Yeah. Okay. So that's the insight and analytics, right? You build a model, you explain to the business, and sometimes the machine learning models are used in production, which means you're going to be working with the product team and maybe the software engineering team, because they would like to integrate the models into the production systems, right? It's not just for marketing or risk teams, it's actually built into the product. Let's say if you run an e-commerce company, then your models can be used for product recommendation. It needs to work in production because when the customers come to your website, they browse some product, you actually want to respond to those customers in real time and generate real-time recommendations. Right. So that's what I mean, deploying things in production. So you need to build ML pipelines and automate ML pipeline. Right. So
Sorry, just a quick question there. So you mentioned about the real-time data, like what kind of I heard that in Azure, in cloud, in fact, there are other technologies where they like they are able to ingest the real-time data.
Yeah.
Like AWS also, I believe there is a cloud functionality which can ingest the real data and analyze it and generate insights. If you can throw
Right.
some light on that, that would be great.
Yeah, so that's the data ingestion part. That's usually done by the data engineering team or the platform team. So when you ingest data in real time, it basically means that, for example, if you're collecting clickstream data when customers come to your website, right, and you want to collect the real time metrics, and so basically, let's say, if the customer has put something in, let's say the shopping cart, right, and but within 5 minutes they didn't check out, and you may send them a notification, right? Or when the customer browse some items on Amazon and then they didn't purchase it, right? But you want to generate like real-time recommendation. So first of all, you need to have a data infrastructure that collects this kind of clickstream data in real time, right? And if you think about the application, like Amazon's running website. So when you go to the website, you log in, you go to different pages, you scroll your mouse and you click on some images and links, right? All of these data points will be collected, but it's usually collected into the production database first, right? Because if you have a NoSQL database or relational database, it needs to sort of log this information. Like, for example, what pages the customer visited, what product they put into the shopping cart, what product they purchased, right? But they're also log data, like, the mouse scrolls and, those information usually generate event streams data. And that data is not necessarily directly ingested into a database, but it can be ingested into a messaging queue, for example, like a logging system, such as Apache Kafka. If you're talking about Azure, it could be Event Hub. It's Amazon, then maybe Amazon Kinesis or just Kafka cluster. When the data is ingested into those logging systems, and then you can send the data to downstream systems. You can send the data to S3 or your Hadoop systems, right, just to store the big data, and then you can analyze those data later. You can ingest the data into your data transformation pipeline. So a couple of minutes later, it's available in your data warehouse, like Snowflake, right? So here you're probably doing ELT. You're going to load the data, clickstream data into data warehouse first, and then you have your SQL workflow to sort of do the transformation. But if we're doing like real-time machine learning, then you need to send that data to your machine learning, pipeline. So there's some feature engineering you need to do, in real time. But of course, doing things in real time is very expensive. So you can't really engineer very complex features. Some of those features, such as the customer shopping patterns, the categories he preferred, the number of things, he purchased in the last 3 months. And all of these features can be calculated, let's say, on a daily basis, right? But what's more useful for you to do real-time recommendation is, okay, in the last minute, in the last 5 minutes, in the last 10 minutes, what did the customer do on your website? So you're kind of doing some sort of real-time, group by aggregation to count like how many events they had in different categories. And that information is aggregated in real time using some sort of real-time computing, like, framework such as Spark Streaming or Apache Flink, right? So you need to be able to ingest the data in real time, and then you need a compute engine whether it's like Lambda functions, but you need some infrastructure to be able to do the real-time aggregation, and those metrics will be used as the features that can be feed into your machine learning model for prediction. So that does some sort of real-time prediction. It's usually pretty complex, but big tech companies will definitely do that. Advertisement company will need to do that as well. But for some businesses like telecommunication, if they're doing marketing promotions, customer churn, it doesn't really have to be real time. So the models can be like trained on a weekly or monthly basis. So it's not necessarily real time. So you just need the right use case for that. Okay. So when you deploy things in production, you need to understand how to automate your ML pipeline, and then you need to build feature store, the features that are used for machine learning. So if you want to do real-time prediction, you may need to build the feature store so the features can be queried in real time, right? You need to understand how to store and persist the model, and also how to serve the model. So this touches on like software engineering a little bit, but that's part of ML engineering as well. You're building APIs, and you also need to know how to scale that. And latency is very important in this case, right? So you can leverage Amazon SageMaker, but a lot of companies will ask the machine learning engineers to build their own APIs. Okay. And then of course you need to, whenever you start to run something in production, you need to turn out logging, because you want to know how your APIs are being queried. If anything goes wrong, you need the logs. Okay. And then we move on to test and learn. So when things are deployed in production, you need to monitor the models, right? Because sometimes the model may not perform really well. You need to know when to pause, when to retrain the model. Or maybe they're like feature drift. So let's say, you used to have 20% of the user base that are, between age 18 and 24. But maybe a month later, somehow that distribution changed. Now you're only down to 10%. So your model is built, right, based on the assumption that you have 20% 18 to 24, age group. But now all of a sudden there's only 10%. So you may have added some older age group, right, customers. That's when you might want to consider like just rebuilding the models to reduce the bias. So you need to do A/B testing, test and learn. There will be like dashboards that you need to build. So it's a pretty big effort. All I'm saying here is that when you're learning, right, in a boot camp or in taking any online courses, you're probably just focusing on the modeling part. Learning how to use scikit-learn, PyTorch to train models, right? If you download the data set from Kaggle, that's the starting point. But there's not much business, context. You don't prepare data, spend a lot of time, preparing data, and you don't spend a lot of time explaining your model or deploying things in production. But when companies are hiring data scientists, ideally, like they're looking for someone who actually has more experience. And that's why I think you need to, when you build your portfolio projects, you need to like pick really good projects to work on. That would be my recommendation. Okay.
Can I ask you a question regarding the logging? Is this similar to audit trail, or is this something different?
It could be audit trail, but it's the logging here is purposely built for data science and machine learning project. You're collecting the metrics you want that's related to machine learning. Yeah.
Okay. Okay.
Yeah. Cool. So next, so I would like to explain the difference between a junior data scientist and senior data scientist, right? Assuming that you're new on the job, that's your first data science job. I think the task scopes will usually be narrow, and you're spending time understanding data, and just be prepared to read other data scientists, scripts or code, and do a lot of code review. That's the best way for you to learn, by the way. But when you read other people's code, you run that line by line, and that gives you an opportunity to understand like the data systems, like so you improve your SQL and Python skills, right? And you might be asked to do a lot of reporting and analytics, but that's a great opportunity for you to learn more about the data systems, the problems, the performance of the existing models, just to get familiar with everything. And reading documentation is part of the job as well, right? And over time, you're learning, the business, right? And a senior data scientist on the other side, will probably get more access to the real client needs, right? They will be involved in meetings to collect requirements. They might get opportunity to oversee the entire project end to end, right? On the implementation side, they might be performing more complex tasks, deploy models in production, and also presenting directly to the client. But as you become more experienced, this is what you expect to do as well as a data scientist. It's not just always about training the models and cleaning data. A lot of times it's project management, understanding business requirements, working with the software team to deploy something, or communicating with the team, with the clients, right? And together you're creating the best practices for your company. Okay. All right. So now I would like to promote WeCloudData. So as you go through the job search process, right? You're going to take courses. I think boot camps, online courses, you're going to gain technical skills. But a lot of people have technical skills out there. And if you join a boot camp or a diploma program, usually these programs allow you to build portfolio projects or personal projects, right? So there might be like 40-50% of people, applicants out there, they have personal projects, but it's still hard to stand out. I think with WeCloudData, one of our advantages is that you have access to real client project. So we sort of let you to get access to the real environment. So you can, you understand how business requirement works, how data science project work, end to end. I think a lot of students got jobs because they have this kind of experience. So that will definitely help you stand out. Okay. That's my quick introduction to the data science job skills. Do you guys have any questions? I think I'm going to pause here and see if you have any further questions. I'm happy to answer them.
I have one question. Can you go back to the slide where you spoke about the model implementation? Yes. So just a quick question. So we have customer propensity models where we are predicting the probability for certain like behavior of a consumer online or in store. So how do you take the model dependencies? Like we need to understand like what is this model dependent upon? Like for example, in the future, if you need to do the model scoring in production, then how important is the understanding the dependency aspect, especially from when we know that the data is coming from external sources, like as you mentioned, the event jobs or some clickstream data or some online or some credit bureau data for that sake, which is a bureau external data, which is like affiliate share data, which we are accessing it, and we got the accesses from the business and we are using it for our modeling needs.
Yeah. Okay. If you're talking about bureau data, it's heavily used in any. So the bureau data could give you the credit score, but most of the banks will need to build their internal model, and they have their internal scoring system as well, right? Which usually is enhanced because they leverage the bureau score. The bureau score, the credit bureau score, basically, let's say you work for one bank, but the credit bureau score will tell you. Let's say the customer has 5 credit cards from 5 different banks. So the bureau score actually give you better idea, like because you only have the customer data in your bank, right? But you don't have other data. So the bureau score can become very, very important. But that's used as part of the signal. So usually, you're going to use the bureau score along with other features, right? Other data your company collect about the customer. That's usually the case. But the bureau score, as you said, is it's one of the dependencies, but that doesn't change very often because you get that on a monthly basis. Typically, how it works is that it's basically through the data engineering ETL process. It's always loaded into one of the tables, and the data scientist is just going to leverage that score. But of course, you always need to do some sort of calibration and just validation to make sure that the bureau score you're getting on a monthly basis, it follows some sort of distribution, and the data cannot it needs to be like if the data is changing dramatically, something is probably wrong, right? So you need some sort of data cleaning and validation process before you can use that. So there's ideally you have some sort of data validation scripts, right? that check the distribution of all the external dependence, like data you depend on. And you want to make sure that month over month or week over week, the distribution drift is not huge. And if you detect that, like say, all of a sudden the distribution is completely different, something's wrong. Like you should probably not use it, or it's like alarming. You have to look into that and find out why. And sometimes it could be the the ETL process that's causing some problems, right? So ideally in production, before you generate the prediction and use that score, you always need to check let's say you prepared, let's say 100 features, but your model in production is using 10 of them. So you always want to make sure that those 10 features you use for prediction every day, they follow some sort of, they will basically need to pass some sort of unit test. For example, my model was trained on a column, let's say city. There are 10 cities, but somehow today you only have 8 cities, or you have 12 cities in your data, and that's a problem. So you need to have some sort of sanity check before you actually do the prediction in production.
I think thank you so much. I think that's really important what you mentioned, because what I've seen is that you mentioned like the model iteration. Like few of times I have seen like the model is rebuilt or it is iterated if some of the sources becomes unavailable and becomes relevant for that business scenario. So in that particular case, they either scrape off that feature or they actually kind of do the rebuild exercise altogether again.
Right. Yeah. Great question. Any other questions?
Yeah, I got to ask you a question. This is if you got, let's say, the source of your data is coming from package, from a vendor package, from different organization, but the same vendor package. However, the level of accuracy of the data is different because of something happened in the organization, the culture of organization. How you organize it in one database in order to run a big data to have the model, predict better because you have a bigger data. What's the technique to make sure that you normalize it or you clean it the same way to make it the same level? What's the idea to do it?
Yeah, when you build machine learning models, typically the data scientists will follow some sort of workflow. If you have data from provided by different vendors, there should be like a feature selection. First of all, like your data might coming from 10 different vendors and also your main database, right? So the data, it depends on how you leverage the data engineering team. The companies I worked for in the past, it's like data science team come up with requirements, and the data engineers will like prepare all the data for them, right? So data engineers, they're more familiar with the vendor, the source data. They're gonna do integration, right? Merge the data from 10 different sources and put that into their main database or data warehouse. They will do some level of data cleaning, and then the data scientists will start from there. They do further data cleaning, right? And they follow their data science workflow
but you know that you can come to a situation that, let's say, let me give you the sample. It'll be easy to explain to the question. Hospitals using the same, let's say, the same vendor package, okay? However, if I collect from different hospitals the same data, some data can be good and some data can be not so good because of the fact that it wasn't entered in the proper way, the culture of the organization. So what I should do in order to, and I put it in one database, I would like to make sure that before I put it, it will be clean to a certain level, so what I do, I have to run different programs and different ideas and different modeling for each different source. Although it's the same coming from the same package, but it's different organizations because it's different hospitals.
I think in this case, like before I even built the models, I want to fix the data. So you're going to do a lot of reporting just to make sure that your data is cleaned properly. But it's meaningless like before you fix the data, right? So I think you need to like aggregate all of these data together, and you have to create some reports and just validate the data. That's not something I would expect the data scientist to do. But data scientists will basically, use these feature to generate the feature, these data sets to generate the
So
features.
who has to do it? Who has to do it? Just for me to understand, who has to do it if not the data science? Because it has to be done. Otherwise, it's garbage in, garbage out.
Yeah, so it depends on I think it depends on the size of the company. I think for a company that has a data engineering and IT team, it should be the IT or data engineering team because you need to build the data warehouse first.
Yes.
Right before you do machine learning, like the company will need to have like basic data analytics and BI, because you're building reports and dashboards on these basic metrics. If you cannot even agree on that, like there's no point of doing data science. So the data should be cleaned before you move on to data science. So if you're building a data warehouse or some sort of database systems, whoever who's doing that needs to make sure that those kind of data problems got fixed, and they have to achieve 90% of that, and then the data scientists can handle the rest and build the rules of handling bad data in their modeling process. But you don't expect a data scientist to fix 90% of the data cleaning issue. That's clearly a data engineering problem, right? So you need to either have the data engineers or whoever who's building the data warehouse to fix that. That would be my
yes, I understand it. Now I know. Okay,
But
now I know.
if you work for a small team, like a startup, right? And we worked on this kind of projects. Like they have it's a fashion company, startup company. They're getting like catalog data from 60 different vendors, right? So before you move on to modeling, again, it's like, it's the data scientist working on that, but it's the data scientist doing data engineering work. Like you have to standardize the catalog, because the apparels, the shoes, like from different companies, even their category name is different, right? So you have to fix those. You have to build the taxonomies. You have to standardize that. That's data engineering effort. But if you happen to be running a lean, small team, then data scientists need to be ready to do that as well. Yeah.
So you have to really introduce a lot of business rules that checks the data before you upload into your main data source, main database. But that's basically what you tell me.
Yeah, definitely. Like whenever you do data cleaning, you need to understand the business rules. You have to talk to those vendors and ask them, why does your data look like this, right? You have to get some clarity, and then hopefully they have some documentation. But yeah, that's how it works.
Okay.
And that's why it's called data science. It's I think data scientists spend a lot of time on data. It's not just the modeling part. Yeah.
No, because you cannot escape from the GIGO rule, garbage in, garbage out.
Yeah. Yes, you're right.
Thank you.
Nope.
I rest my case.
Any other questions? Cool. Yeah, if there are no other questions, yeah, I think that's it. That's the end of this session. If you would like to know more about WeCloudData's Data Science Bootcamp, you can go to our website, WeCloudData.com. And I think Adam has shared some links with you. So yeah, feel free to check it out, and you can always talk to us if you have the need down the road to work on a real client project or get some mentorship hours to help you get a job. But that's what we do, and we're pretty good at it. So come talk to us if you would like to become a data scientist. Thanks, everyone, for your time.
Thank you, everyone.
Thank you
for
very much. Thank you very much.
Yeah.
It was very helpful.
Insightful. Thank you.
Thank you very much.